Hello and welcome. Finally, we have been waiting for this one, dot product. And I'm so excited to share with you because dot product is going to be one of the most versatile tools in your toolbox for H2 Maths vectors. And at first it might feel a bit confusing or a bit overwhelming, right? But imagine yourself to be like a toddler looking at a toy for the first time, just trying to figure out how it works. Okay? If you play with it enough, which translates to if you do enough practice questions, you start to figure out what this toy is about and you start to have fun with it. Talking about practice questions, I will spend about 2 to 3 videos on just dot product. At the end of every video, there'll be a practice question to really gel and solidify the concepts that we talk about in these videos. So without further ado, let's get into dot product. So dot product, one of the many forms is this. Let's read this together. A dot B is equals to mod A, mod B cosine theta. Remember that mod just means the modulus function. The modulus function removes direction and just gives you the size. You don't have to memorize this because you use it so often that it will commit into your muscle memory. Let's take a look at some interesting properties of the dot product. So the dot product operates between two vectors and the result is a scalar. So this is why sometimes you might hear people refer to the dot product as the scalar product. They're actually the same thing. Now for the next one, if the dot product between two vectors is equals to 0, then we can conclude that the two vectors are perpendicular to each other, provided that the two vectors are not zero vectors. So the dot product becomes a tool to check for perpendicularity. So if the dot product is 0, it will mean that at least one of these things is equals to 0. However, we can rule out mod A and mod B because if mod A and mod B are not zero vectors, they will have some magnitude. Therefore, cosine theta must be 0. Now we take a closer look at theta, which is the angle between two vectors. The angle between two vectors really is just between 0 to 180 degrees. And between 0 to 180 degrees, cosine theta is equal to 0 when theta is equal to 90 degrees. And if the angle between two vectors is 90 degrees, then we can conclude they are perpendicular. Now moving on to the next one, if you dot a vector with itself, you get the square of its magnitude. A dot A will be mod A times cosine of the angle between the vectors. If the two vectors are the same, then the angle between them is 0. There will be mod A cosine 0. And since cosine of 0 degrees is equals to 1, that will give us mod A squared. Now moving on to the next one, number 5. A dot B is the same as B dot A. If you look at the definition, A dot B is mod B cosine theta. Then B dot A will be mod A cosine theta, which actually is the same thing. Quickly to number 6. The distributive property tells us that the dot product kind of is like expanding brackets. If for some reason you cannot add up B plus C, then you can actually do A dot B plus A dot C. Okay, so this is the expanding brackets property. And finally, the last property I'm going to talk about today is associativity. What that actually means is if you take a vector dot with the scalar multiple of another vector, you can actually take the scalar multiple and move it anywhere you want, in front of B, in front of A, or in front of the result of A dot B, right? And that will come in really, really handy later on. So now it's time to do a practice question to solidify our understanding of all these interesting properties. So this is the practice question we'll be doing today. Take some time to read this question, pause the video, take out some paper and pencil, and work this through. So this question says that we have a vector A with size 4, a vector B with size 5, and the angle between A and B is 45 degrees. So I did a quick sketch over here. Can you find, for the first part, what is A dot B? We're going to use what we just learned. A dot B is equals to mod A, mod B, cosine of the angle between them, 45 degrees. So mod A given by the question is 4. Mod B given by the question is 5. Cosine 45 degrees is square root 2 over 2. And this will evaluate to 10 square root 2 units. And that is the answer for part 1. So part 2 wants me to find the dot product of 4A plus 2B and 3A minus B. The problem over here is I'm not given explicitly the column vector of A or the column vector of B, which means I cannot do the addition of vectors. So what I'm going to do instead is expand brackets. Remember the expanding brackets properties? First of all, I'll take 4A and dot it with 3A. Next, I'll take 4A and I'll dot it with negative B. Next, and finally, now remember the property where we have the dot product of scalar multiples of vectors. We can move that scalar multiple anywhere we want. So taking a look at the first one over here, I'm going to collate the scalar multiples. 4 times 3 is 12. And remember that A dot A, when the vector is dot with itself, you get the square of its magnitude. Moving on to the next one, this will be a negative 4 times of A dot B. And for the next one, this is going to be 6 times of B dot A. Now remember that B dot A is the same as A dot B. And for the last one, great. So mod A is given to be 4. So this is 12, 4 squared. And this actually is equals to 4 times. Remember the A dot B is a scalar, so this will be some number. And this will be the same number. So this combined together will give me positive 2 times of A dot B. And mod B is given by the question to be 5. 12 times 16 is going to be 192. 2 times of A dot B. We actually found this in part 1 over here. A dot B is equals to 10 root 2 units. Finally, we can write our answer down. And that is the answer for part 2. Welcome back to part 3, where we have to find the square of the magnitude of the vector A minus B. Can't do A minus B because we don't have the column vectors of A and B. If a vector dot with itself gives you the square of the magnitude, and over here I have the square of the magnitude of this vector. So I can probably reverse this into the dot product of A minus B with A minus B. And from this step, I can do expanding brackets again. This will be mod A squared. This is negative A dot B. This is also negative A dot B. This will be mod B squared. Alright, and now we can substitute numbers into these. And the answer will be, and that's the answer for part 3. So I hope you found this video helpful. In the next one, we're going to look at another form, another way to use the dot product. So until then, I'll catch you on the flip-flop.